Hi, here's a MyMaths walkthrough of speed time graphs 1631. Okay, so the thing about speed time graphs, there's two things to know. First of all, the gradient of your line is the speed that you're going to travel at, and the area underneath your line is the distance that you've travelled. Okay, so the gradient, if we remember from work on straight line graphs, is remembered as the rise over the run. So it's just a straightforward division question. How far up have you risen in that section divided by how far you've run across for that section. So if we look at the first question, we've got a speed of 24 meters per second and we have a time of 13 seconds. So all you've got to do to work out the acceleration is starting from here, you run across 13 and you rise up 24. So this acceleration is equal to 24 divided by the 13. At that point you just grab your calculator, whack the buttons in. So 24 divided by 13, and the answer is 1.84, goes off forever. So 1.84 going off forever. And then the round, you just look at the second one because you want around a one decimal place, so you look at the second one. If it's less than 5, it stays the same, so it's 1.84 meters per second squared. So there's your first answer. This one, it was a retardation. It's called retardation when slowing down. You got to make sure that you don't leave it as an acceleration, which would be just be a negative answer. So it's the same idea. So the rise over the run, you can see a run across 5 seconds, so it's over 5, and it's actually risen or gone down 74. Now if I was doing this normally, I would say the acceleration is equal to, it's gone down minus 74 over 5, and then I get your calculator, do the 74 divided by 5, and you get an answer of minus 14.8. But the question's asking for a retardation, so the retardation is just the 14.8 meters per second squared, because retardation just means how quickly are you slowing down. So that's the answer for this question. The next question, I've got a maximum speed question. So the max speed, the top speed that we've got there is 40 meters per second, and that's up here, so that's just the biggest you've got to. And the maximum acceleration, now that's the steepest part of the graph, because the steeper it is, the quicker you accelerate. So that's this section here. So when I do the rise over the run, I've got to go, the run is, I go 4, from there to there is 4, and then going upwards, I've got 20 going upwards. So the acceleration, or the maximum acceleration, is the rise of 20 over 4, which is 5 meters per second squared. Okay. So that's the first question on my page, or the first set of questions on my page. Let's have a look at the second lot. So on the second lot, I've got the graph again, and it's saying to me, first of all, my first question, there it is there, what's the acceleration when the time equals 4? So when t equals 4, so somewhere on here, now notice it's all the same, so I can just do the whole thing, and that'll be good to go. So the acceleration when t equals 4, so I'm just concentrating on the whole graph because the gradient stays the same all the way. So when t is 4, the gradient is the same as there. So the run is 6. I go 6 across. Acceleration equals, let me this all the way because I keep bashing it. 6 over, oh no, something over 6, and I go up 7, don't I? So it's a rise of 7 from 15 to 22 is a rise of 7. And that's going to be equal to, and I'm going to one decimal place, yes. So grab your calculator, just do 7 divided by 6, you get 1.16. So 1.16, and that'll run on to one decimal place, that's 1.2, because the 6 is bigger than 5, or 5 or more, so meters per second squared. The retardation, so how quickly is it going down when t equals 13? So we're in this section of the graph, so we've got the retardation is, so we're going across 6. Remember, you just, because the 13, let's say 13 is about there, it doesn't really matter that you take the whole line, because it's all the same gradient at 13 as anywhere on that line. So it's 6, and the total rise was 22. So we get the calculator, we do 22 divided by 6, and then we get 3.666. So 3.66 runs off forever. Rounded to one decimal place, sorry, is 3.7 meters per second squared. The total distance travelled. Now the total distance is just the area underneath the curve, or the graph, sorry. So what we want to do now is work out all the areas. Now there's lots of ways to work out the areas. This one to start with is a 6 by 22 rectangle. This is 6 by 22. This is 22, this is 15, and this is 6. So I'm going to do 3 types of areas. First of all, the area of a triangle is going to be 22 times by 6 divided by 2 because it's a triangle. So I've got an area of 66 in here. In this one, I've got an area of 6 times 22 because it's just a rectangle, is 132. And the area of this one, now this is a trapezium on its side. So to work out trapezium, what you do is, in brackets, you add up the 2 parallel sides, so 15 plus 22, close your bracket. You multiply by the distance between, so multiply by 6, and then you divide by 2 to get the area of a trapezium. So that one's 111. I could have split that into a triangle or rectangle, but I just wanted to go for 3 different types. So the total distance, so the distance travelled is equal to these 3 added together, so 111 plus 132 plus 66, so I've got 309, and then the average speed, so average speed is just distance, 309 over the time taken, so distance over time is speed. So that's the total time was 18 seconds, that was the total distance. Get your calculator and you can figure that out. 309 divided by 18 equals 17.16, goes off forever, 17.2 because I'm rounding that off, and that's just going to be in meters per second. And that's the end of the speed time graphs. Have fun.